Better means a fascination of flying with products use less resources. Generative design is not just a tool for us. For us, it's a philosophy. So at Airbus, our vision for the future of flying is how we design our products and think of ways we manufacture it in a way we have never done before.
Great design has to work for the end user. Our goal at Build Change is to retrofit 10 million houses over the next 10 years. We are saving lives in disaster-prone countries where people live and work while keeping the homeowner at the center of the process.
Better design tools for us means we are able to do bigger, crazier, more exciting things for our guests. At Walt Disney Imagineering, we create immersive stories for our guests to experience in ways unlike anything they've ever imagined. Disneyland is a place where guests would get the opportunity to step into the world of the stories that they love.
For us at Airbus, better starts here.
At Build Change, better starts here.
At Walt Disney Imagineering, better starts here.
Please welcome to the stage President and CEO Andrew Anagnost.
That's hard to come up after. Good morning, everybody. Having a good time so far? All right, let's see if we can keep getting better. All right, so what does the future look like? Now, you know, an economist might say that automation is going to take half of our jobs. A journalist might point you to the bleak headline about our bleak future. And of course, a technologist like me might tell you that only technology can save us. Maybe the truth lies somewhere in between. Because although technology can be a positive force, there are forces pulling us in other directions. On the one hand, we know that a growing population is inevitable, as is a world with more automation, because so much more is needed. But at the same time, we fear there will be less jobs and less of our planet's scarce resources. So what do we know about our future with any certainty? We know that more and more people are joining the middle class every day. Over half the global population can be considered global middle class today. Now, I know there are many definitions of what middle class is, but whatever your definition, the fact that 4 billion people enjoy mobility and prosperity is enormously good news. But with this increasing prosperity comes increasing demand for more housing and hotels, more automobiles, and more airplanes. We know that more is inevitable. Yes, as we make more things for more people, we also know that we create more potential for negative impact. And that making all we need with less harm to the planet and to people is a reality that we all need to face up to. So how can we solve a problem of such enormity and such complexity? It's a massive challenge, but it's also a massive opportunity, especially for all of us here in this room. I believe that better starts here. And let me tell you what I mean by better and how technology can help us get there. And there are 3 areas I think we all have an impact on, and they're all completely interrelated. First of all, we have the opportunity to better use the world's energy and materials. You've heard me talk about using less, and yeah, that's part of it, but it's also about better. More renewable energy and more circular materials. Our energy and material choices ultimately impact people. But if we can make our dependence on fossil fuels a thing of the past and build a world where people everywhere benefit from clean air, better is also about the health and resilience of the entire population. That means designing products without harmful materials that compromise our safety or using supply chains that compromise people. It means designing buildings that prioritize health and well-being, and designing cities that are resilient in the face of climate change. And finally, we all know that automation is changing jobs, but it's also creating the opportunity for more meaningful work, better work, and a path to prosperity for more people. Together, we have an opportunity to create a more sustainable, more equitable, and more prosperous future. A future that's better for the growing middle class, but also for those still striving to get there. So let's take a look at what these 3 aspects of better look like in construction, manufacturing, and media and entertainment. Now we'll start with construction. Now we all know today construction creates about 1/3 of all global waste. If we are to build what our growing population needs, we can't keep wasting energy and materials the same way we do today. We need to fundamentally rethink the way we build. Now, one company doing just that is Marriott. Now, Marriott is the world's biggest hotel chain, and their revenue is increasing, their pipeline is growing, they're opening more properties than ever before. There's just one problem. Marriott has a huge bottleneck. They can't build what their growing business demands. Now, why is that? Because half of the US construction workers are now over 45. And the job is seen as just too dirty, dangerous, and dull to many younger workers. This lack of skilled labor over the last decade is why the average US hotel has taken longer and longer to build. So 5 years ago, Marriott set out on a journey to learn how modular construction could help. Since 2014, they've built more than 30 low-rise modular properties, and the last year, they were ready for a big leap. At 26 stories, the Nomad Hotel in Midtown Manhattan is certainly big, as is the $65 million Marriott is investing. It will be the world's tallest modular hotel. But this isn't about creating a big hotel. It's about creating a beacon for the whole industry. And their partner for this is Skystone. Now, back in 2014, Skystone was a pretty small company, but the way they thought wasn't. They design modules that are volumetric. Now, this means they get fully fitted out in a factory. with less material, less waste. And they make them as steel frames, which means they're more configurable, and less concrete is needed to install them together on site. In theory, the economics stack up just as well as the modules themselves. But theory only gets you so far. Skystone wanted to put this into practice using automation to drive efficiency across all phases of the hotel's construction. And central to Skystone's automation effort is Revit. They used Revit to develop a library of parts that can be mixed and matched to spec, using a service built on our cloud development platform, Forge. Now that service is called Kit Connect, and it's used to publish concomitant libraries to the cloud from where they can be assembled and configured into a single central model. So if a component like a window is swapped out, the bill of materials for each module remains consistent and accurate, because the changes propagate through the Revit model and to any other tool referencing it, like Bing 360, which Skystone is using to share 3D documentation across all phases of the project, making all the information available to all the trades when they need it. And Skystone has just started to use our pre-construction tools to keep their auditing as tightly managed as their factories. As Marriott scales up its investment in modular, so Skystone has to scale up its manufacturing in parallel. These modules aren't constructed, they're manufactured. There's an assembly process, a supply chain, and tight quality control, with less waste, less cost, and less risk. They're using robots for what robots are good at, the dirty and dangerous job of welding the steel frames, and they're using people for what people are good at. Like, for example, the high-end finishes in Marriott's modules require people's expertise and attention to detail. All 168 modules will soon be on a single container ship on their way to the port of New York. From there, they will be trucked overnight, one by one, to a plot that is just as tight as the rest of Midtown. So tight, in fact, it would be really difficult to get traditional materials onto the site. But trucking them in from the port is straightforward, as is craning them into place, hanging them off the concrete core, and hooking them up to the services. Over half the work is still done on site, but the work has changed for the better. It's simple, it's predictable. Now, the Nomad Hotel is on track, it's on time, and it's on budget, and it's due to open next year. Now, all building projects involve the juggling of energy and materials, of time, cost, and quality. And Skystone has partnered with Marriott to build hotels of better quality in less time with less cost. But beyond that, there's also less disruption to the neighborhood, less noise, less dirt, less wasted materials. And because each module is insulated individually, they're quieter, and they're more energy efficient. Because the building's performance, Marriott qualified for a floor space credit. The city granted them an extra 5,500 square feet that will become a rooftop bar. It'll make the hotel more attractive, bring more guests, and more revenue. Now, maybe you're not building high-rise hotels, but if modular can do this for Marriott, just imagine what it could do to help you use energy and materials more efficiently. You know, rethinking how we build the new hotels, new housing, and new infrastructure is very important, but it's just one part of a larger system. We also need to rethink how we repair our existing housing and our old crumbling infrastructure. At the same time as we build the new world, we're going to have to rebuild the old. Now, to talk to you about this, I want to invite up the CEO of Build Change, who is bringing economic health and resilience to communities around the world. Please welcome Elizabeth Hausler.
Thanks, Andrew. Good morning, everyone. A couple of months ago, a house collapsed in Medellin, Colombia, killing 3 people. There was no earthquake. It was just a normal home. just more heavy and less reinforced than it needed to be, just like hundreds of thousands of brittle brick buildings throughout the emerging world. But a house collapsing under nothing but gravity loads is a canary in the coal mine. Because when a house like this collapses, the people who live there lose not only their home, but also their source of income. In places like Medellin, families often run a business, like a store or a restaurant, out of their home, or maybe they rent out a second story for income. When the big one hits Medellin, or Jakarta, or Manila, or Bogota, or Guatemala City, or Tehran, the loss of life, the loss of housing, the loss of economic progress, the loss of social progress will happen on a much larger scale. What's this got to do with me? I grew up in a small town outside of Chicago, and my dad built houses. He owned a small construction business and worked for 50 years as a brick mason. And he and my mom are here in the audience. Thanks, Mom and Dad. So guess what my sister and I did for our summer jobs? We laid bricks. We built houses, just like my dad. I loved working with my hands, building things, being out in the fresh air, telling jokes on the construction site. Andrew, I didn't find my construction job to be dirty, dangerous, or dull. I could see what I'd accomplished at the end of the day. We'd built a home. We worked hard for my dad, and goodness knows he worked hard for our family. Neither of my parents had the opportunity to go to college, but for us, they saw a college education as an opportunity of better. They encouraged my sister and I to become engineers. When I was in grad school studying engineering, completely enthralled by the science and technology behind preventing buildings from being damaged in earthquakes, I found myself still looking for purpose. Just then in 2001, an earthquake in Gujarat, India, killed 20,000 people. That's 4 or 5 times the number of people in this room, gone in less than a minute with no warning. And the majority of those killed, women and children. Most people died because their unreinforced stone masonry building collapsed on them. This is a man-made problem. I realized maybe I could help. Maybe I could use my engineering and my construction skills for good. I spent a year in India on a Fulbright fellowship, an idealistic engineer, thinking, of course, we can design and build disaster-resilient homes. But as I wandered around villages talking with homeowners, I realized that it wasn't that simple. I met families who had been given geodesic dome homes. Geodesic domes are great for earthquakes and wind, very secure. But they're not easy to live in. They don't have enough light. There's poor ventilation. There's no ability to divide the interior space. I met homeowners with contractor-built houses who still slept outside 10 years after the earthquake because they were excluded from the design and construction process. They couldn't trust that their house was built safely, that enough cement was used in the concrete, that the structure was sound, that they could sleep at night. We need to understand the materials and architecture that work for the culture and the climate and the client. If we are to build healthy and resilient communities, we need to respect how people want to live here and now. We make small changes to existing building types to make them safe and usable to the people living in them. Simply, we need to find solutions people want. Isn't that what designers do? Fast forward, today I lead Build Change, a nonprofit focused on creating earthquake and climate-resilient housing in emerging nations. We do this in partnership with 3 groups. First, the government. Second, the private sector. And third, and most importantly, the homeowners. But who is we? A team of over 200 incredible people, mostly from the countries where we work, structural engineers, project managers, finance experts, builders, policy advocates, coders, designers. And together, we've protected $1.5 billion of housing assets worldwide, and we've impacted the lives of nearly 500,000 people. Thank you. And we've relied on technology from the start and have been working with Autodesk products since we first bought AutoCAD 2D 15 years ago. In those early days, we used AutoCAD to churn out unique floor plans for every homeowner. We walked around villages with our handheld Garmin GPS units to keep track of locations before there was any sort of accessible cloud. We manually compared satellite images before and after disasters to determine who lost their homes. We used clipboards and spreadsheets to manage bills of materials and to track building quality and progress. We made the engineering simple and prescriptive. If your wall is longer than X, you need a cross wall. If your window is larger than Y, you need a lintel beam. So the process was simple and technology-powered even back then, but it still required person power and skill, a heck of a lot of time, and a ton of paper. We could do maybe 300 or 500 houses a year. Those are still big numbers, but it didn't scale beyond that. In those early days, we were limited by the technology available at that time. Look where we are now. We asked ourselves, how can we work with technology available now to make every step of the design and construction workflow shorter and more efficient for both new housing and for strengthening existing housing, retrofitting, where every house could be a little bit different. Today, using Revit and Dynamo scripts, we can automate retrofit design for like types of buildings. We code in Dynamo the structural engineering retrofit rules and use Revit to produce a complete design, a 3D model, bill of materials, cost, and construction drawings. What once took our team of 3 people 4 to 5 days, 3 people, 4 to 5 days, now takes 1 person 3 hours. That's 97% less time. Even if every house is a little bit different, the process, the design process, is automated. But we think we can do even better. Here's what we're doing next, and this is really exciting. We're using artificial intelligence to change how homes are assessed. It's time and resource intensive to send engineers and architects to visit every house, to make structural assessments, to measure the dimensions. We built a tool that uses AI to quickly assess whether a building can be strengthened or retrofitted. The tool uses photos that the homeowner takes on their smartphone and uploads to our cloud. It looks at things like the continuous length of solid wall, the proximity of wall to the corners, the length of wall between openings. We've trained the machine through image capture, and all that data then tells us if it's possible to retrofit the home. These technology advances are key to scale, scaling our efforts and scaling our impact. Why? Because the World Bank says that 3 billion people will be living in substandard housing by 2030. 3 billion. That's 1/3 of the world's population. We're not just talking about the poorest of the poor. Lack of access to safe, resilient housing affects the bottom of the pyramid, up through the middle class, in our markets in Asia, Latin America, and Caribbean. If we're going to address the need for safer and better housing, we must move quickly, and technology is the key to unlocking that problem. The quicker we can assess and design a home, the quicker we can get to construction, and the quicker people can live safely in that home. And that's not all. We'll bring better housing, but also better work to these communities. Local construction workers can access skills training and job after job after job to support their families, enabling them to build their own livelihood. But we have to be cautious here. Let's not let technology eliminate people from the design and construction process. Let's use it to enable them to make the choices that are right for their family. Using virtual reality, the homeowner can walk through the Revit model of their home and make design decisions, truly keeping those who will live in the home at the center of the design process. Back to Colombia. Technology alone can't save the world. The government of Colombia knows that retrofits, strengthening homes, will help support their citizens. They know that preventing a disaster costs less than 20% of the cost of rebuilding after one. And they plan to invest more than $3 billion in government funds for housing. But we want to be sure that's safer housing. In partnership with Build Change, that investment can be taken much further. We're close to building a complete technology platform for strengthening existing housing in Colombia and the Philippines and Indonesia and beyond. An end-to-end solution that spans initial assessment through design, through access to financing, through construction, quality control, and sign-off. We start in Colombia, but we've got to raise $3 million to fund the program, to deliver safer housing for hundreds of thousands of people in Colombia and beyond, and all those construction jobs it will create. We can't scale just by building more housing. We need to make existing housing better. If there's anything my experience has taught me, it's that better housing means healthier communities and happier people. At Build Change, our goal is 10 million homes strengthened in the next 10 years. That's our idea of scale. 10 million more resilient homes built in partnership with a homeowner, creating local construction jobs. Together, we can change lives immediately and forever. That's our opportunity for better. Thank you.
Elizabeth, I never get tired of hearing your story. You are an impressive and inspiring person. I get inspired. We need at least 10x of you in the world. I think what Build Change is doing is amazing. I'm also really proud that Autodesk has been connected with you for a while and supporting you and using technology to connect these homeowners and the businesses and the governments together in ways they never thought they could. I think we've given you $1 million over the last few years.
Thank you, yes.
We want you to get that $3 million. We want you to get it badly. So today we're going to give you another $500,000.
That's great.
All right? And all of you can help too. All right? I hope you'll consider giving to Build Change and help Elizabeth hit her goal to retrofit those 10 million homes in 10 years. Thank you so much, Elizabeth. Thank you for everything you do.
Thank you.
Let's give Elizabeth a hand again. So our material choices can put the health of entire communities at risk, or they can make these same communities more resilient. We have to make better choices in building projects and in all of our projects, because these choices ultimately impact people. Now, perhaps nobody knows this better than Volkswagen. The last few years have been dark times for Volkswagen. The emissions scandal was a difficult chapter in its history, but they've learned lessons from their past, and they are reimagining their future around electric. They're spending $50 billion over the next 4 years to build electric vehicles. They plan to put 22 million EVs on the road by 2028. And one of the first of these is the long-awaited successor to the VW van, the ID. Buzz. It's really a beginning of a new chapter for Volkswagen. And to launch this effort, the team at Volkswagen wanted to do something to bring their past and their future together.
Good morning, AU.
Now, for those of you of a certain age, this probably brings back memories. Hopefully, most of them positive. I know I had friends that had one of these, at least a couple of friends, and we spent lots of time driving around in these things. You know the engine's so simple you can fix it on the road, no problem. It's just an air-cooled engine. Not this one, this is electric, but it's a fun car to take on a road trip. So here's what they did. They took this 1960s bus and they retrofitted it with an all-new electric drivetrain. Now, they also know that going electric also means a heavier vehicle. So they wanted to explore how it could be lightweighted. So we worked with Volkswagen to reimagine one of the most fundamental parts of any vehicle, the wheel. Yes, we thought we'd help Volkswagen reimagine the wheel. Now, these particular wheels are 18% lighter. But beyond that, and more importantly, we helped Volkswagen reduce the time to design and manufacture them from 18 months to 6 months. The traditional route takes so long because the process is relentlessly linear. First, the designer sketches out her new idea, one sketch, one idea, and from this single idea, the designer gets equally singular engineering input, and it's this linear process that eats up so much time, pushing ideas and input between departments, back and forth between design and engineering. What if Volkswagen could flip this process around? Instead of sketching out an idea, drawing lines to describe it, and then getting engineering to use their simulation expertise to discover how it would perform, what if instead the two teams could work together to discover the design? That's exactly what they did. Their designers worked with the engineers to describe the problem, the goals, the constraints, the forces at play, and generative design helped them discover what was possible. The engineers described the load cases and physical constraints up front, and the designers sketched a set of initial shapes that helped guide the wheel's eventual form. They evaluated dozens of possibilities. They made several prototypes at our Autodesk technology centers, and all of this gave them the confidence to print 3D molds that would allow them to cast the wheels in aluminum. They were able to prove out that this approach was viable. Now, of course, Volkswagen knows if they experiment with something like this and put it into scaled production, that it's going to impact their supply chain. But they also know that changes to their supply chain will be playing a significant role in their new future. Volkswagen's investment in generative design hasn't just changed the parts they make, it's changing their vehicles, their supply chain, their entire ecosystem.
See you at the expo.
I had the pleasure of hanging out with the engineers that worked on that, and I'll tell you, there's more in that car than you can imagine in terms of what they're experimenting with. It was really exciting, and it was amazing to see the enthusiasm of the engineering team for what they were doing. You know, and it's also clear that as automation changes what we work on, it also changes how we work. So what do we need to change in order to prosper? Now, one company that has been thinking about this is Airbus. You might recall that 4 years ago, they used generative design to make a partition that was half the weight of the one it was designed to replace. This potentially saves 500,000 tons of CO2 every year. And from this important interior component, Airbus has moved on to optimizing critical exterior components. And they've started with the vertical tail. Everybody knows how important the tail is. They optimized its leading edge to be as stiff as possible and to weigh as little as possible. And because the vertical tail is critical to how a plane flies, they also designed it to be impact resistant. And now they are looking at what they've learned on this and figuring out how to apply it to the wing. All of this grew out of the work Airbus and Autodesk did 4 years ago. And today, we are working together to figure out how automation could help Airbus with a much bigger challenge. From their early work on structural optimization, they've shifted their focus to systems optimization, from parts like these to the processes that go into making them in factories like this one, where the A350's wings are assembled. Production of the wings involves sophisticated process, like carbon fiber layout. But the assembly line is a different matter. It involves a lot of human labor, drilling, cleaning, bolting, riveting, sealing, and all these different tasks require different tools. Going back and forth between the wing and the tool trays, the carts and the storage racks involves a lot of walking. And while this walking might feel like work, it really is not work at all. It's simply activity. So we helped Airbus see how one bay could be configured for multiple wing types. They used generative design to explore how tools, locations, and configurations could be optimized for this process, as well as all the processes for all the variations of the wings from the different generations of the A350. We managed to reduce the distance of the key travel paths while also minimizing congestion and bottlenecks. Now, the line workers are absolutely getting in their daily steps, but they're also spending more time assembling the wings. It's a more productive factory and a more configurable factory. But this was just a proof of concept for something much bigger and much better. Airbus is now using generative design to optimize an entirely new factory for installing engines. It will open on its campus in Hamburg, Germany, just next year. And they embarked on this complex challenge for one very simple reason. The most favorable site on their campus is triangular. And the plot's smaller than Airbus would like. These are not ideal constraints. But Airbus knew that this shouldn't constrain their thinking. So they explored two paths. One path examined what a bigger building with a triangular footprint might look like, and the other path explored how the same factory might be optimized to fit into a smaller rectangular footprint. Whichever path they eventually choose, Airbus knows that the factory's form should follow its function. So they identified 10 different sets of variables to optimize for. Variables that covered the social, the environmental, the financial, and operational aspects of its design. The social aspects of the factory were absolutely a key consideration, as Airbus wanted the best conditions possible for its workers. And like so many of you, they wanted a building with the best possible environmental certification. But the factory needs to be affordable as well as sustainable. So Airbus considered the major financial drivers, the number of unique structural members, the length of these members, and the building's overall footprint. Cost matters to all of us, but what's really critical to Airbus was the way the factory operated. So they looked at the operational drivers, the different flow paths through the factory. The green lines you see represent the logistics flows, the loading and unloading and prepping of them and inspecting them. The blue lines represent jacking, jigging, and the many parts that need to be assembled. The red lines are the parts being moved through the different paint booths. We helped Airbus look at all the different flows of people and parts between these three key areas. Airbus was able to evaluate hundreds of options, and from these, Airbus chose several designs that looked promising. And then the team narrowed it down to these two. Both have better flow scores than the existing standards. So either factory functions more efficiently. The engines are installed more quickly, the logistic flows are more efficient, and so are the workers, because they take fewer steps each day. Overall, this one scored 40% better than the baseline. This one has a smaller footprint, which means that it fits squarely on the constrained site. And both options are less costly. So now they just need to choose the one that suits them best. To build a factory that creates more prosperity for the company and better conditions for its workers. It's a space where everyone can prosper. The opportunity to create a better future, a more sustainable, more equitable, and more prosperous future is an opportunity that we all share. Now, maybe you're not building at the same scale as Marriott, but perhaps scaling up an investment in modular could help you use energy and materials better. And you might not have quite the same impact as Elizabeth's work. But just as automation is helping build chains, make entire communities more healthy and resilient, maybe automation can help you further scale your impact. Finally, you don't have to be Airbus to think about how technology can help you do better work, how it can eliminate the non-productive, and how it can help you prosper. Technology can help us create a more prosperous future, but we need to create better experiences for people as well. Now, we've talked about better hotels, better housing, better cars, better airplanes, and better factories. Now, how might all of these things come together in a city-scale system where people's experiences are not just better, they're happier? Now, here to talk about that and creating the happiest place on earth is Asa Kalama, Executive Creative Director at Walt Disney Imagineering. Asa, welcome.
Morning, Andrew. Good morning, everyone. Making the world a better place is something that I think about a lot. And it's not just me. At Walt Disney Imagineering, it's the thing that drives us, all of us. Together, we build experiences that transport our guests to imaginary worlds, that immerse them in the stories that they love, and that fill them to the brim with wonder and delight. We share the fundamental belief that happy people make the world a better place. And so we create these experiences for people to enjoy together, in the hopes that when they leave, they do so uplifted and inspired. And with over 150 million people around the world visiting a Disney destination each year, our job is a big one. To imagine and to design all of its theme parks, its resorts, cruise ships, and attractions. It's a big job, but it's also a really big opportunity to impact the lives of millions of people. My role as creative director involves working alongside incredible artists, architects, programmers, and prop builders to design and make experiences that are truly fantastical. And it is a distinct privilege to get to help an idea grow from a tiny napkin sketch into something this big. But big really doesn't do it justice. Take Walt Disney World, for example, in Florida. It's 43 square miles. That's twice the size of Manhattan. It is truly massive, home to 4 theme parks, and each theme park is really a small city in and unto itself. And like Andrew said, the street-level experience is just one part of a much larger system. Because like all cities, there is an incredible amount of unseen infrastructure. We have our own power plants, water plants, our own transportation systems. But unlike all cities, ours are home to mystical jungles, old western towns, and of course, fairy tale castles. Creating these city-scale experiences is a massive design challenge. But today, I want to show you something we've built that's even more massive. I want to take you behind the scenes to show you what it takes to build a galaxy. It has been an absolute dream getting to work on the physical expression of one of our most epic stories, Star Wars. And an epic story requires an epic backdrop. Star Wars Galaxy's Edge is a fully immersive land built with a level of detail that rivals any set ever created for the movies. It's the largest single-themed land expansion in the history of Disney parks. And creatively, technically, and logistically, it's one of the most ambitious projects in our history. It's a place where a guest can find their own place in the galaxy, where scoundrels and bounty hunters and the ne'er-do-well of the galaxy plot to trade or resupply. It's a remote trading port called Black Spire Outpost that features 2 massive show boxes that enclose a whole lot of Disney magic and incredible engineering, as well as 5 restaurants and 7 shops. And because, Star Wars, it's also home to 7 amazing spaceships. The largest of these is over 100 foot long. It's the Millennium Falcon, which guests board on a wild, interactive smuggling adventure. And to put that scale in perspective, if it were placed on its end, it would actually be taller than Sleeping Beauty's castle. And it's big because the whole experience is big, as was the team behind designing it. They were drawn from over 140 different disciplines from all around the globe. Concept artists, designers, facility architects, landscape architects, interior designers, show set designers, graphic designers, media designers, ride engineers, software developers, as well as a host of amazing trade partners. A team of massive talent working across different disciplines and time zones, which is why coordinating all of their efforts was a Herculean task, and one that was made possible by BIM. In fact, the final experience that our guests enjoy today is the product of over 600 different models, all integrated into a single source encompassing design, fabrication, and installation. Now, to give you a sense of this complexity, let's take a journey into one specific portion within the Millennium Falcon. Fans have dreamed, many of them for decades, of finally getting to step aboard the most iconic ship in movie history, which means delivering on how they've always imagined it. And one of the most recognizable locations on board the ship is the chess room. And our version needed to be indistinguishable from the films. Like this interior set, which was just created at Pinewood Studios in London for the latest installment of the Skywalker saga. Now, the film production created a set of drawings to build from, so surely we could just use those for our attraction. Well, actually, no, right? Theirs was purpose-built for filming to a very different set of requirements. Our version needed to be engineered to withstand the test of time, as well as the enthusiasm of our guests. So, though we were incredibly lucky to have a set of drawings and access to the original production designer, we had to create our chess room from scratch. There were 2 major constraints that drove our design: the structure and the interface with a ride system. The site footprint drove the overall shape of our building, and the ride system occupied a big portion of that space. This left only odd-shaped voids into which all of our themed show set spaces had to be located. It's really sort of like building a ship in a bottle. The design needed to be coordinated with incredibly small tolerances. Why? Well, because an inch here and an inch there is the difference between a snug fit and a HVAC duct running right through the middle of your holographic chess table. And our show set and ride and facility teams were all in different locations, working on their respective designs concurrently. Here, actually, we see the void into which the chess room was built. It's wildly irregular in shape, with a delightful steel column running right through the middle of it. Our show set team worked to squeeze the chess room in between that structural steel, the walls, all while maintaining that connection to the ride load station. Coordinating electrical, AV, fire protection, and show control systems, that was an iterative process with the design evolving over time as each discipline put more detail into the model. And as all designs change, this one was no different. So midway through the design process, the envelope of the ride vehicle increased. But because the ride team drew that envelope in the model, we discovered it very quickly in a routine clash detection. And we were able to redesign the ductwork long before we ever got to site. One of the other side effects of squeezing rooms into voids is that none of them are built with 4 right-angle walls. Okay, that's a lie. There's one back-of-house equipment room, but other than that, every other space has like 5 or 6 walls, and many of them are curved. So when you end up plotting these drawings, what you get is this largely incomprehensible mess that becomes very difficult to visualize, yet alone use as a coordination tool. So tumbling around the model became the primary way we were able to clearly articulate to each other what we were actually building and also how we were doing. I used it to track progress in real time, which allowed me to sort of refocus the team on particular issues or make design decisions to react to emergent clashes. I'm a creative director, but I care about construction details just as much as I do the creative vision. And so we push Revit to its limits, just like we push so many tools. And in fact, our projects are often so complex and so unique that we often find ourselves bumping up against the edges of what tools are capable of doing. And indeed, we often find ourselves creatively misusing software. And one great example of this is Autodesk Shotgun. You might know it as a tool for tracking media assets, but we found it profoundly useful for managing our entire inventory of props and tracking our supply chain from myriad global sources all the way to the field. But perhaps the most direct benefit of working together in a shared BIM model was velocity. We were able to collapse our sequencing and have multiple disciplines all working in parallel, often at different levels of detail, on things that would otherwise need to happen sequentially. And in the end, what this allowed us to do is deliver one of the most technically challenging attractions we've ever created months ahead of our target turnover date, which, most importantly, meant that we were able to open earlier than we had originally planned. Because as excited as our fans have been to finally get to step into a galaxy far, far away, we have been equally excited to share it with them. And the complexity of the design and all of the advanced tools we use to build it are just that, tools. These are things that should be totally invisible to our guests. What we hope they do see is a place where they feel welcome to imagine, to create, and to play. I mean, this is why we created Star Wars Galaxy's Edge. To be a place where parents can share the stories they loved as children with their children, where guests can imagine themselves to be who they've always wanted to be, where a daughter can see her father as the child he once was, and where they can leave feeling like the Force is with them. Thank you.
Asa, you probably have one of the best jobs in the galaxy.
I cannot complain.
Yes, so thank you for sharing a little bit of the Disney magic with us.
Absolutely.
I really appreciate it, and I know everybody else did as well. So let's see, I got marching bands, people saving millions of lives, the happiest place on earth, Star Wars. How do I follow all of that? What the heck, why don't I just try this? All right. Now here's what you should take from all of this. Remember all those staged-looking pictures that Asa was showing? It's real. People really look that goofy at Disneyland. All right, they do this stuff. My wife's going to kill me for these pictures. But so, you know, we were just there last summer. This is just from a few months ago, all right? And, you know, obviously, we had an amazing time, you can tell. You know, and while the rides have changed over the years, the way Disneyland brings a family together really hasn't. You know, for those of you who've been there, you know that Disneyland, even for exhausted parents, is still the happiest place on earth. I can remember just how magical my first visit to Disneyland was, and it's the same for my kids. Walt Disney Imagineering has helped create those memories by building incredible rides that incorporate play. Rides that are helping Disney attract more visitors and build more revenue. That's the magic of making something playful. And we could all use it, a little bit of that magic, in our own work, right? You know, so for example, at Autodesk, we are starting to bring the element of play into our tools to make them easier to learn. So you can use our software. You can see what skills you might need to learn next, and maybe you could even rank yourself alongside your peers and compete. That's what we're exploring with the Autodesk Learning Engine, bringing learning into your work environment, directly into the tools you use. Now, you recognize that guy right there. This isn't fake. That is my command flow that I used to do the generative type workflows that VW did. So I wanted to figure out how generative design worked. I wanted to figure out how to clean up the part. I wanted to figure out how to render it, how to manufacture it. And the tool helped me know where I needed to go. And it was fun. It was exciting to compete with people. It was exciting to see how I compared to others. It terrifies the Fusion engineering team, because now I know exactly what works and what doesn't. But, it's an amazing experience to have play put into what you do every day. Now, this is just in Fusion today, so it's really early days. But over time, the learning engine is going to help you adapt your skill set for the future. And come on, if a CEO can do it, all of you who are way better at this stuff than I could ever be can do it too. Right? You can learn lots of amazing new things while having fun at the same time. And we know you care deeply about improving your skills, not just because you're here at AU, but because you told us so in the survey we kicked off here last year. You might remember we wanted to find out how automation is changing the work you all do. And so we commissioned Deloitte to write a report on what the future of work looks like. The report examined the demand for jobs within your industries, the skills you supply, and the ecosystems you all work in. On the demand side, the report recommended that companies invest in continuous learning and treat their workers as centers of value rather than cost centers. So what might that actually look like? You remember the team at Volkswagen who worked on the bus, the designers and engineers? Here are the skills they used during the course of this project. Now, they're mapped out in the learning engine. The designer did a lot of sculpting and surfacing. They used the more fluid and creative tools to explore form because they're designers. Now, while the engineers did a lot of part modeling and simulation, their work is more focused on analysis and function, which is why there's this communication gap, this language barrier between their work. However, over the course of the project, generative design gave them a common language, one where they could explore form and function together. Both the designers and the engineers could contribute to finding the best solution. And rather than pushing ideas and input back and forth across this gap, both groups grew skills over the course of the project that brought them closer together. As we continue to build the learning engine, we are changing how we think about learning. What's more, you don't just come to AU to learn how to use our products. Many of you come to AU to certify themselves in them as well. And now you can get certified online anytime. And there's going to be free vouchers for those of you who are here today to do just that. So look for a message in your AU app today, and the first 2,000 are going to get these vouchers, the first 2,000 to respond. All right, we're also introducing 2 new role-based certifications at AU this year, and we're piloting credentialed courses too. So you can be recognized for your skills, and employers can find good people to fill their jobs. So what did the report have to say about the skills you supply? It said that our industries are seen by some as dirty and dangerous, and that in order to attract talent, we need to change the way we talk about this work. We need to give people the opportunity to see how these industries are changing and the important role technology is playing. And we want to support other organizations who are helping change these narratives, like the California State University. We're giving them $1 million to help with a new integrated design, engineering, and manufacturing facility. This will help expose their students to new technologies that will help them develop new skills. Now, it's planned for their campus in Northridge, just north of Los Angeles, where there is a diverse learning community of almost 40,000 students, 40,000. Many of them the first in their families to go to college. And Cal State Northridge is already giving them a leg up. The school has an incredible track record of turning adversity into prosperity. It's recognized as one of the top 10 engineering schools in the US for traditionally underserved ethnic groups. And the president of the university, Diane Harrison, Dr. Diane Harrison, is sitting right there. Thank you for all the work you do with these populations that need what you do desperately. You know, our investment will help them prepare their students for the future of making. But beyond that, it will increase the quality of the region's manufacturing and the quality of its manufacturing jobs. There are more of these jobs in LA County than any other US county. It's an incredible manufacturing hub with an incredibly diverse population. And that diversity will be part of the engine that helps fuel more opportunity in the future. I believe that it's our social and moral responsibility to give everyone, everywhere, access to the tools they need to address the challenges they have. Now, we began making software free to students back in 2012. And since then, we have given away millions of licenses each year. Our goal is to help everyone learn the skills they need today to help them thrive tomorrow. Now, finally, the report also said that the supply and demand for your skills doesn't exist in a vacuum. All of you work within a bigger ecosystem. So what can we do to promote cross-sector collaboration? Now, that's where our technology partnerships come in. There are many different disciplines represented in this room. So one of you out there is probably an architect. I know you're there. You might be sitting next to a game designer, all right? Somebody out here works in automotive or in aerospace. And you're probably sitting next to a contractor somewhere. What do you all have in common? You all need to unlock your data and connect your teams. Every single one of you. You all have the same coordination and data flow problems. They're just for different things. And with the Forge platform, you can create new automated workflows that add new value and help you connect those teams and data flows. Companies you work with today are already doing this. You might remember our partnership with Esri. Esri has used Forge to build a bridge between BIM and GIS to help automate the aggregation and visualization of GIS data. Unity has used Forge to bring BIM data from Revit into real-time environments in one click, so that your teams can visualize and experience their BIM projects in high fidelity anytime, anywhere. And this year, I have a new partnership to share with you. Tomorrow in the design and manufacturing keynote, we're announcing our partnership with Ansys. Now, many of you already know them well, and we know their simulation expertise can help propel our generative design technology even further. But Forge isn't just for others to build value on. It's something Autodesk is building value on as well. And in tomorrow's AEC keynote, you'll see how we've used it to connect teams, workflows, and data across the design and construction ecosystem. One of the reasons I'm really excited about Autodesk Construction Cloud is the way it closes the loop between our design tools and our newest construction solutions. It really will help owners, general contractors, and subcontractors collaborate better in less time with less risk. All of these partnerships use Forge to build on the data that flows through your ecosystems. And organizations like Skystone, Build Change, Volkswagen, and Airbus are starting to see the value that is emerging from building on our platform. So at AU this week, think about how automation can help you connect the disciplines you work with. And when you're in classes, look for opportunities to eliminate the non-productive. Think about how you can grow your expertise and your creativity, and focus on what adds value to you and to your business. That's the opportunity of better. That's what we're working towards at Autodesk, a platform for better. Better workflows, better outcomes, a better world. Better starts here. Thank you, and have a great AU.
Pump up the jam, pump it up.